Okay, this is Saxon Advanced Math Lesson 78. This is the hyperbola. In order to understand our hyperbola, we need to go ahead and do a quick review on the ellipse. This is just a couple of lessons back. If you need to go back and watch the lesson on ellipse so that you understand that a little bit more in depth, that's completely understandable. The ellipse has two focal points and also has a unique a formula to it that we're going to talk about here in a minute, a little bit of a key that we're going to use for finding the hyperbola. The very first thing we remember is that this is the formula for ellipse, right? X squared over a squared plus y squared over b squared. And a and b could change depending on if it's a vertical or horizontally larger ellipse. But when we looked at this is the a is going with the x because that's our wider direction. And we look at and we say, well, how far is it from the origin over to here? And that would be whatever a is and negative a. And then b and negative b distances. What's different, or was something that we have talked about but not in depth or explored, is there's a constant value. If I took and drew any point on this ellipse, and I drew two lines from that point, like this one here, from the ellipse to the focal, edge of the ellipse to the focal, the addition of distance 1 plus distance 2 is a constant number. Which means no matter where I drag this around the outside of the ellipse, distance 1 and distance 2 will change, but they change at a constant rate. Which means that as distance 1 gets larger, distance 2 gets smaller at the same exact rate of change. Therefore, their addition of the two of them are always constant. Let's talk about for a hyperbola here. In a hyperbola, you have two different ways hyperbolas can be laid out about the origin that are a standard method. And that would be like this way where it's horizontally, or this way where it's vertically. They both have focal points and they both have vertices, right? And these are our vertices and these are our focal points. So they have two foci and two vertices. Now, when I look at that, I also have a relationship between the two distances. So if I went from any of the foci, so focus 1 or focus 2, and I went to either edge of the ellipse, or of the hyperbola, and I took those and I said distance 1 minus distance 2, and it really could be distance 2 minus distance 1. It does not make a difference. The absolute value of that will always be a constant number. And because of that subtraction, it works out nicely. So sometimes you'll end up with a negative, but the absolute value kills that negative, and it always ends up as a constant number. The formula for a hyperbola is x squared over a squared minus y squared over b squared equals 1. The only difference between this formula and this formula is that negative sign. Now that negative sign is going to have some different connotations to it that we're going to look at in just a moment. But just remember that this is the formula for my horizontal hyperbola. Well, if I changed my x and y around, notice that the a and b still stayed the same, because it really doesn't matter, but my x and y changed around, and my x became in the negative fraction, it makes it a vertical hyperbola. Now, let's talk about why that is by looking at the example 78.1, which is sketch this graph of this hyperbola. And they gave us x squared over 9 minus y squared over 4 equals 1. And if we were doing this on an ellipse, most of you have already figured out if I just took the root of this of 9 is 3 and the root of 4 is 2, so I would say, oh, it's laying horizontally and it's going plus or minus 3 and plus or minus 2, and there I have my ellipse. But it's not an ellipse because of this negative. And let's talk about what happens when we start putting some zero values in for x and y. Well, zero values for x and y would mean it would end up on the vertices, right? When x is 0, it's on the y vertice. When y is 0, it's on the x vertice. And so we're going to put each one of those values in and see how that plays out. If I put a 0 in on this one here for y, I end up with 0 over 4, which is 0, and subtracting 0 doesn't mean anything. That leaves me with x squared over 9 equals 1. I multiply both sides by 9, right? And that's going to give me x squared equals 9. And I take the root of it and I realize that there's a positive and negative value. And so far I'm saying, well, yeah, this is the same thing I did with the ellipse as plus or minus 3. So when x is 3, y is 0. When x is negative 3, y is 0. This is so easy, right? Here's where it changes. And it's not that it's harder, it's just a little more unique. When I put in my 0 for my x value, I end up with negative y squared equals 4, or y squared equals negative 4 when I solve for y, and then I take the root of it. And here's why I have a problem. I end up with y squared equals the root of negative 4 right? Or I'm sorry, y equals the root of negative 4. Well, that's a problem because now I have a negative, and this is going to be an imaginary answer. So when I write that appropriately, I say y equals plus or minus 2i. Root of 4 is 2i, because I had to substitute in that I for the root of negative 1. And this is where I start getting some interesting answers. Because how do I graph an imaginary number? Well, I can't. So I know it's not graphable. By definition, that's what an imaginary number is. And I realize that when x is 0, negative 2 is I is y. And when x is 0, positive 2i is y. So if I plot those points out, and I said, well, okay, here's my 4 points that I came up with, right? My 1, 2, 3, 4 points. And I laid those out. If I draw a box through those points, like this, I end up with this interesting little box that has isotopes flowing through it. So if I connect my corners, right, I will end up with this x. These are values that I would not be able to find for my graph, because it's going to give me an imaginary number. And I know that because it's going through here. So I know it can't be anywhere on these lines here. So I start with getting this x. Then I realize that this is a vertice and this is a vertice. By definition, we knew those were vertices, right? And I can therefore connect and say, well, it has to be going this direction and this way, because it's like this graph right here, or this formula here, not like this one. Notice that the y is negative, not the x. So I know it's opening horizontally on either way. And then I go ahead and just sketch these in. But the problem is, I want to find out the equation of the lines of the isotopes. Well, when they were vertical isotopes, like for a tangent, or their vertical graph, that was pretty easy. They were just vertical lines. They were really easy to find the isotope. But these aren't vertical lines. These have a slope to them. Well, if I can get the equation of a line, remember that's y equals mx plus b, but I realize that it's crossing through the origin. Well, if it's crossing through the origin, b, or the y-intercept, is automatically 0. So I can substitute that right in there and say, well, y equals mx. Now all I need is a slope. Well, what is slope? Slope is rise over run, right? So if I looked at this equation here and I said, well, what's the rise on this equation? Well, the rise on this equation is going up 2 for every over 3, right? And it doesn't matter if I start here and go up 2 over 3. But that's going to give me a 2/3 slope. So y equals 2/3 x is the equation of this line. Well, I need to find the equation of this line. Well, it's the same idea. It's still the same rise and run. It's just going down instead of up. So it's going to be a negative 2/3 of x. So these are the two equations of the isotopes where it will never hit. These are what the hyperbolas look like. And I know that it's opening sideways because it's a negative y, which is where that's going to put it. If it was a negative x, it'd be exactly the same thing, except it'd be opening this way. Let's look at example 78.2, and we'll put this together with this one. Here they gave it to us, and they said y squared over 4 minus x squared over 25. Oh wait, there's my negative x. Therefore, I know it's going to be opening and both vertically up and down. That's how I know that. Now, I skipped a lot of steps here, putting in zeros, because I can look at this, and so should you be able to say, well, this is going to be 2, and this is going to be 5, so I can say 0, 5, and 2, right? So I'm going to say plus or minus 2, and plus or minus 5i. Well, therefore, I can say it's going to be up and down 2, left and right 5. I draw my box, and I'm ready to find the equations of the lines. I know the vertices. I can sketch those. The equations of these lines would be rise 2 over 5. That's this one. So y equals 2/5 of x. This one is y equals negative 2/5 of x. These are really simple when you start to see these patterns. Now, look at example 78.3, and I'm going quickly because this is just a shortened version of this one. 78.3 asked you to come up with the equation. Well, we're going to do this the same way we did when we found the equation for the ellipse. So what we are going to do is we're going to say, well, let's move that 36 over to the other side. We'll divide everything by 36 because I need it to equal the value of 1. When I do so, I end up with the 36 in the denominator. I simplify, get 9 and 4. Well, that's easy. That's plus or minus 3. That's the negative 1, so that's plus or minus to I. Then I go ahead and graph that. I remember that because it is a negative x value, right, instead of a negative y value, that it's going to be open vertically, just like this one did. And I start plugging in my isotopes. I graph both my vertices, and then I find the equations of the line. Well, once again, equation of the line, y equals mx plus b, b is 0. I start plugging in my rise, 3, my run, 2, 3 over 2. For the one going this way, or a positive slope, the one with a negative slope is negative 3 over 2x, and I'm done. And these are really simple once you realize how they work. You can very easily graph, and this only works. This is ellipses that are centered about the origin and hyperbolas that are centered about the origin. They make these really nice little formulas that work out. And we can very easily find the isotopes, the point where it doesn't graph, and also the direction of the hyperbolas by just looking at which one is negative, the x or the y.